Hello everybody, good morning all of you. My name is Kumar Anuj and I welcome you to Chandra classes. So to continue with our discussion with respect to timeline of global environmental actions, in today's lecture, we are going to discuss about ozone layer protection regime. It means that global efforts, combined coordinated global efforts to protect the ozone layer. But first of all, I mean, before going into those details that global efforts and how they just tried to protect the ozone layer, we'll have to first look into some relevant other details with respect to the ozone layer. For example, what is exactly ozone layer? I mean, what is ozone layer, where it is situated, and how it is important for us? And what are the concerns related to the ozone layer? How the global community just got awakened or got triggered to protect the ozone layer. I mean, what were the background initiatives or background motivating forces, those kind of triggered or just brought the global community together to just put down some coordinated global efforts to protect the ozone layer. So to have a kind of very structured, kind of systematic discussion, so that's why we are going to look into these details about ozone layer protection regime. First of all, we'll just discuss about the ozone layer. So that's why we are having, so that we are having the entire kind of understanding of the entire picture. Uh, so first of all, to continue with without making any delay, just we are going to discuss about ozone layer. If we talk about ozone layer is a layer of gas that is known as ozone, O3. O3. O3 is triatomic molecule of oxygen. It is triatomic molecule, triatomic molecule of oxygen, that is O2, meaning the most stable or the naturally stable form of oxygen is O2, but O3 is the triatomic molecule of oxygen, triatomic molecule of oxygen, triatomic molecule of oxygen. Oh, triatomic molecule of oxygen. So this is the ozone kind of gas which is found in the ozone layer. But now what is ozone layer? Where exactly it is found? आखिर ओजोन लेयर कहाँ पर situated कैसे है? कहाँ पर situated है? So to discuss with, for example, this is our Earth. Ozone layer is found in the atmosphere of the Earth. But where exactly it is found? Just let's see it. For example, this is our beautiful planet Earth. This is Earth. Earth. Then after we have various layers of atmospheres around the Earth. Various layers of atmospheres around the Earth. For example, this is one of the layers around the Earth, layer of atmosphere. This layer is known as troposphere. Troposphere layer. Troposphere layer. The next layer in the atmosphere of the Earth is stratosphere. 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 So the ozone layer, if we talk about the kind of distances of these layers, the expansion of these layers, then troposphere expands. Troposphere expands from the surface of the Earth up to around 12 kilometers. Up to around 12 kilometers. This is the average expansion. This is the average expansion of the tropospheric layer. Average expansion. And if we talk about stratosphere, it is in between around 12 kilometers to 50 kilometers. to 50 kilometers. So the stratosphere layer, which is the second closest layer to the Earth, is situated between 12 kilometers to 50 kilometers, I mean at the distance from the Earth. This is the next layer after the troposphere. So in this stratosphere layer, our ozone layer is found. This stratosphere layer of atmosphere that we have around the Earth, in this layer, the ozone layer is also found. The concentration of ozone gas is also found, and that's what we call the ozone layer, the concentration of ozone gas. And while talking about ozone layer, the main concentration, the main saturation of ozone gas in the stratosphere layer is specifically between 15 kilometers, from 15 kilometers to 35 kilometers. 35 kilometers. 15 to 35 kilometers. This is the, for example, this is the main saturation. This is the peak concentration of ozone layer, of ozone gas. Peak concentration of ozone. Peak concentration of ozone. So this peak concentration of ozone is found in between 50 kilometers to 35 kilometers above the surface of the Earth, in the stratospheric layer of the atmosphere of the Earth. So this is the location of ozone layer, which is mainly concentrated between 15 kilometer to 35 kilometer from the surface of the Earth. Now, this ozone gas, when we talk about ozone, O3, it is formed, for example, in the stratosphere, some oxygen molecules, O2, some oxygen is present, dioxygen format, O2. And when ultraviolet radiation hit the ozone molecules, hit the oxygen molecules, then this oxygen gets broken down into atomic form, oxygen and oxygen, some of the oxygen. Then the remaining remaining oxygen in O2 form, when this atomic oxygen gets attached with O2, then it turns out to be O3, ozone. And that's how the ozone is constantly being formed in the stratosphere and constantly being broken down as well through the ultraviolet radiation. So that's why the cycle keeps on taking place and ozone layer remains intact and just constant in the stratosphere. That's how the things happen. So this is about the ozone layer in the stratosphere. Triatomic molecule of oxygen. Ozone is triatomic molecule of oxygen, and its concentration is in stratosphere. Stratosphere, layer of the atmosphere of Earth. 90% of the oxygen, 90% of the ozone is found in stratosphere. Some amount, less than 10%, is also found in troposphere, near the surface of the Earth. We'll talk about that later. So this is the kind of ozone layer that we have in the atmosphere of the Earth. Now the next important thing is that what is importance of ozone for us? I mean, why we are so much concerned about ozone? Why the global community is coming together to bring coordinated actions? सारी global community क्यों आ रही ओजोन को प्रोटेक्ट करने के लिए? It means that ozone is somewhere important for us. Otherwise, why we people would be running to protect the ozone layer? We are not so silly. I mean, हम क्यों ओजोन को प्रोटेक्ट करने के लिए भाग रहे होते? Something is there that ozone is important for us. That's why the global community is bringing coordinated efforts to protect the ozone layer. So what is the importance of ozone layer for us? What is importance? The importance of ozone layer is that it saves us from ultraviolet radiation. It absorbs the ultraviolet radiation, saves us from ultraviolet radiation, saves us from UV radiation. And specifically talking about UV radiation, for example, UV radiation. When we talk about UV radiation, it could be divided in three different radiations: UVA radiation, UVB radiation, UVC radiation. We can divide on the basis of intensity and wavelength. As much as we go towards this side, the wavelength increases and intensity decreases. So UVC radiation is the shortest wavelength of ultraviolet radiation, shortest and more intense. So our ozone layer, it blocks UVC radiation along with the oxygen present in the atmosphere as well. Oxygen also plays an important role to block UVC radiation. So UVC radiation is completely blocked, almost completely blocked by O3 and O2, meaning ozone and oxygen present in the atmosphere of the earth. When we talk about UVB radiation, this radiation is largely blocked by ozone layer in the stratosphere. And UVA radiation, which is in the longer wavelength as compared to other UV radiations. So it is not blocked and it reaches to the surface. Of the earth. But the most deadly ultraviolet radiations, UVC radiation and UVB radiation, they are blocked. UVC completely blocked by ozone together with the oxygen, UVB largely blocked by the ozone layer. Oxygen does not play much role here while blocking UVB radiation. But that's why, since the UVB radiation is blocked by the ozone layer, that's why ozone layer is important for us, because UVC radiation could have blocked by oxygen alone. So there is not much concern about UVC radiation. It is also completely blocked by ozone plus oxygen as of now. But this UVB radiation is alone largely blocked by ozone layer, not completely blocked, because some of the UVB radiation reaches to the earth, कुछ जो UVB radiation है अर्थ तक पहुंच ही जाता है. And if this UVB radiation would have been allowed to reach the earth uninterrupted, if there would not have been any ozone layer, अगर कोई ozone layer ना होती और ये UVB radiation पूरी तरह से अर्थ की सरफेस पर पहुंच रहा होता, then what kind of impacts, what kind of side effects we would be having of this UVB radiation reaching to the earth uninterrupted. So if there would not have been the ozone layer, this UVB radiation would be reaching to the surface of the earth uninterrupted, and then we will be having various kinds of concerns diseases like skin cancer caused by UVB radiation, skin cancer, eye diseases, cataract, eye problems, DNA and crop damage, So these are the effects of the UVB radiation reaching to the surface of the earth. But since our ozone layer, it blocks UVB radiation largely, so that's why those impacts are not too much visible for us on the surface of the earth. If there would not have been this ozone layer, we would be having these kinds of implications of UVB radiation reaching to earth. So that's what the ozone layer does. It protects us from tremendous diseases, from tremendous problems as we could face in the absence of ozone layer. अगर ओजोन लेयर ना हो तो हमारी क्रॉप डैमेज हो सकती है, हमारी आईज में प्रॉब्लम हो सकती है, कॉन्ट्रैक्ट इशूज हो सकते हैं, कॉन्ट्रैक्ट इशूज जो आईज में होते हैं, we can develop skin cancer, we can develop DNA change as well. DNA can also change because of UVB radiation. So that's why we can face various issues related to the health, related to our food, meaning crops, if the UVB radiation is reaching to the surface of the earth uninterrupted. That's what the ozone layer does. It just absorbs the UVB radiation largely, and that's how it protects us from UVB radiation, specifically when we talk about ozone layer. So this is the job which is done by ozone layer. That's why it is important for us. It saves us from UV radiation, and that's how it saves us from various problems like skin cancer, like eye issues, like crop damage, DNA damage, saves us from various issues. Now, what is the concern? Okay, if the ozone layer is there, we got to know in a stratosphere, 10%, yeah, one more thing to be discussed here, that when we discuss that 90% of the ozone is found in stratosphere, since the ozone layer which is found in the stratosphere, it protects us from various problems by almost partially blocking the UVB radiation. So that's why the ozone which is found in stratosphere is popularly known as good ozone. Popularly known as good ozone. Good ozone. इसको हम पॉपुलरली क्या कहते हैं? गुड ओजोन. गुड भाई जो हमारे लिए अच्छी है, क्योंकि अगर ये ना होती, if there is no ozone in the stratosphere, we would be suffering with a lot of problems. So that's why the ozone which is found specifically in stratosphere, that is known as good ozone, and it is the 90% of the entire ozone of the atmosphere which is found here in the stratosphere, and its peak concentration is found in between 50 kilometers to 35 kilometers from the surface of the earth. So this is good ozone. But less than 10% of the ozone, is also found in troposphere, and that is specifically near the surface of the earth. 10% of the ozone, less than 10% of the atmospheric ozone is also found in troposphere. So there is any tricky question that ozone is found, and then they are giving various options: only in stratosphere, only in troposphere, only in mesosphere, or in stratosphere and troposphere. So the tricky question could be, ozone is also found in troposphere, less than 10%. The concentration is very less, but ozone is technically found in troposphere as well. And the tropospheric ozone is largely concentrated at the lower layers of the troposphere, meaning around almost the surface of the earth. And now this ozone which is found in the tropospheric ozone when we talk about tropospheric ozone, along with the volatile organic compounds, it is the major component of smog, which is a pollutant. So, tropospheric ozone is a major component of smog. The formation of smog, as we see, it makes the situation critical, especially in winters. When the smog is formed, the air just becomes so much unbreathable that we develop breathing issues. हमें breathing issues होने लगते हैं because of the smog. So this smog, the important component of this smog is tropospheric ozone. So that's why it is a pollutant. That's why this tropospheric ozone is a pollutant. If we talk about tropospheric ozone, just remember, we are not talking here about stratospheric ozone. That is good ozone, protects us. But tropospheric ozone is a kind of pollutant as well as just not only pollutant. The tropospheric ozone also works like GHG, greenhouse gas. Works as GHG, greenhouse gas, because it blocks the long wave radiation, infrared. Yeah, long wave infrared radiation just emitted from Earth. We know that Earth gets the radiation in the form of shorter waves and emits back the radiation in infrared format in longer wavelengths. So that radiation the Earth emits is largely blocked by ozone gas as well, which is present in the troposphere. Some other greenhouse gases are also there, like carbon dioxide and various others. But this ozone gas, which is there in the troposphere, we know as tropospheric ozone, it also blocks the infrared long wave radiation emitted by Earth. And that's how it just contributes in global warming or climate change. So that's how we see that tropospheric ozone is not good for us, not good. It is a pollutant as well as a gas which creates the effect of global warming. So this kind of tropospheric ozone, that's how, because of these reasons, to this tropospheric ozone, we popularly call it as a bad ozone. And when we talk about stratospheric ozone, that is good ozone. But largely when we talk about ozone layer, we are talking about stratospheric ozone. जब भी हम ओजोन की बात नॉर्मली करते हैं, then we are usually talking about stratospheric ozone. नॉर्मली हम stratospheric ozone layer के बारे में ही बात कर रहे होते हैं, because that is 90% of the concentration of entire ozone in the atmosphere of the Earth. And since it protects us, that's why we also need to protect that. क्योंकि ये ओजोन लेयर हमें प्रोटेक्ट कर रही है, that's why to reciprocate we want to protect the ozone layer as well. अगर ये ओजोन लेयर नहीं रही तो हमारा प्रोटेक्शन चला जाएगा. We will be in trouble, in danger. The human life, the survival will be in danger. So that's why we want to protect this stratospheric ozone layer, and we want to fight with the tropospheric ozone because it is a pollutant as well as a greenhouse gas. So this is about the ozone layer and its importance of stratospheric ozone, remember. And then after, okay, that's okay, the things are going on. Then where is the problem? If there is ozone layer, it is protecting us and protecting us from ultraviolet radiation, UVB radiation specifically to be precise. Then where is the concern? आखिर problem हुई कहाँ पर? The problem started happening when we started realizing that the ozone layer that we have in the stratosphere is in danger. वो खतरे में है. the the concentration of ozone is drastically reducing at some parts of the ozone layer. जब हमने notice किया, specifically in 1970s, we started noticing that the ozone layer at some places around the earth, since it is in the stratosphere around the earth, in the atmosphere of the earth, we started noticing that at some places the concentration of ozone is drastically reducing, and it could be kind of disastrous for us if the concentration reduces, because the places where the concentration of ozone will come down from a particular kind of limit, then it can give the free passes to the UVB radiation. अगर कहीं पर concentration घट गया है तो वो तो UVB radiation को freely pass होने देगा, और अगर UVB radiation वहां से पास होकर अर्थ तक पहुंच गया, then we can be in trouble, as we have discussed. कितनी समस्याएं यहां पर हो सकती. So that's how the concern was, specifically the concern started arising in 1970s. In 1970s, when researchers warned, उन्होंने चेतावनी दी, they warned the global community that CFCs, chlorofluorocarbons, they named CFCs, researchers, they named CFCs, chlorofluorocarbons. These are the chemicals used in aerosols, in foams and refrigerations. So these are kind of chemicals. Popularly, they were being used in foams, aerosols and refrigeration, etc. So researchers in 1970s, they warned the global community. उन्होंने global community को warn किया sorry, कि ये CFCs जो popularly use हो रहे हैं all around the globe, in foams, in refrigeration, in various other kinds of ingredients and formats, when they reach to the stratosphere, they said that when these CFCs they reach to the stratosphere, then they break down under UV radiation. Stratosphere, then they break down under UV radiation, because UV radiation breaks down these CFCs when they reach to the stratosphere. And what happens because of this breakdown? When CFCs are broken down by the UV radiation, then they release chlorine atoms. And these chlorine atoms, they destroy ozone molecules. This was the basic concern raised by the researchers in 1970s, that CFCs, those are being popularly used nowadays, back then, when they reach to the stratosphere layer where the ozone layer is found, where the ozone gas is concentrated, then these CFCs are being broken down by the UV radiation, and by this breakdown there is the release of chlorine atoms, and those chlorine atoms, they destroy ozone molecules. And you'll be surprised to know that one chlorine atom can destroy around 100,000 of ozone molecules. लगभग 1 लाख ओजोन मॉलिक्यूल्स को अकेला एक क्लोरीन एटम ही डिस्ट्रॉय कर सकता है. This is the potential of chlorine atom. That's why we just decided to ban CFCs, the use of CFCs. क्योंकि CFCs जो है वो हमारी ओजोन लेयर को इंडेंजर कर रहे थे. And this concern was started being raised in 1970s by the researchers. Sorry. So after this concern, which was raised in 1970s by the researchers, by scientists, and they also gave supportive documents. Then after the global community started being concerned, उसके बाद ग्लोबल कम्युनिटी को भी चिंता होने लगी कि अगर ऐसा हो रहा है, ऐसा सब कुछ है, तो हमें इसके बारे में क्या, हमें एक्ट करना होगा बिफोर द सिचुएशन वर्सेंस, अगर सिचुएशन और खराब हो जाए उससे पहले ही हमें एक्ट करना होगा. देन वी सी द कोऑर्डिनेटेड ग्लोबल एफर्ट्स, द कोऑर्डिनेटेड ग्लोबल एफर्ट्स टू टैकल द इशू ऑफ ओजोन लेयर डिप्लीशन. तब हमने देखा कि ओजोन लेयर को हमें डिप्लीशन से बचाने के लिए, डिग्रेड होने से बचाने के लिए, वी सी ग्लोबल कोऑर्डिनेटेड एफर्ट्स, ozone layer protection regime, and to that we call ozone layer protection regime, meaning combined global efforts, coordinated global efforts to protect the ozone layer. So the initiatives, the global coordinated initiatives, they were started being discussed by the global community once the concerns arise in 1970s. Now when we talk about global initiatives, global initiatives, global initiatives, global initiatives for the protection of ozone layer, for the protection of ozone layer, for the protection of ozone layer. So the first important initiative that was taken, the coordinated global initiative that was taken, is known as Vienna Convention. Vienna Convention. Vienna Convention. Vienna Convention. What was this Vienna Convention, my friends? What was this Vienna Convention? इसमें क्या डिस्कस किया गया, क्या था, कब हुआ? These are important for us. They could be the part of our questions. So that's why I request you, my friends, to pay your utmost attention here. So when we talk about Vienna Convention, it took place in 1985. 85. Where does it take place? It takes place in Austria. Austria. So not Australia, Austria. So this Vienna Convention took place in 1985 in Austria. So this is the first important thing associated with the Vienna Convention. Now this was the first international treaty, first international treaty to address the issue of ozone depletion. To address the issue of ozone depletion. The issue of ozone depletion, my friends. Depletion. Issue of ozone depletion. This was the first international treaty. ये पहला ऐसा जो कुछ global coordinated effort हुआ. As we saw that in 1970s, when the concerns were raised by the researchers, by the scientists, then global community started coming together. तब global community साथ आना चालू हुई, and the first coordinated effort was put down by the global community, was put before the public by the global community. That was in 1985 and named as Vienna Convention. Ab, the important thing associated with this convention is that this was the first international treaty to address the issue of ozone depletion, as that was being talked. Now this was a kind of framework treaty. This was kind of a framework treaty. Since it was first, so इट वॉज जस्ट ट्राइंग टू डेवलप अ फ्रेमवर्क। ये एक फ्रेमवर्क अब एस्टेब्लिश कर रहे थे। जब हम कोई पहला कोई इनिशिएटिव ले रहे होते हैं तो हम बहुत ही स्पेसिफिक नहीं हो जाते हैं, सेक्टोरल नहीं हो जाते हैं। वी जस्ट ट्राई टू थिंक ओवर इंटायर फ्रेमवर्क कि एक हम फ्रेमवर्क ऐसा कैसे बिल्ड करें जिसपे हम पूरे ग्लोबल कम्युनिटी को साथ ला सकें और पूरे जो प्रॉब्लम्स की जड़ तक पहुंच सकें, एंड देन वी कुड एड्रेस दैट। तो दिस इज अ काइंड ऑफ फ्रेमवर्क ट्रीटी। ये फ्रेमवर्क ट्रीटी थी कि सभी पार्टीज को चलो साथ लाओ और देखते हैं क्या इशूज हैं, उन्हें कैसे एड्रेस करना है, सब डिस्कस करते हैं, फ्यूचर में कैसे इनिशिएटिव्स लिए जाने हैं। सो दिस वाज अ काइंड ऑफ फ्रेमवर्क ट्रीटी, एंड दैट्स व्हाई it was having non-binding targets. Non-binding targets. Non-binding targets. इसमें जो भी टारगेट्स बनाए गए, सीएफसी को रिड्यूस करने के जो भी टारगेट्स बनाए गए वो सब नॉन बाइंडिंग थे। कोई बाइंडिंग टारगेट नहीं थे कि हमें इतने वर्षों में या हर एक जो है पार्टिसिपेंट को इतना इतना सीएफसी प्रोडक्शन या सीएफसी का यूज रिड्यूस करना होगा। Those targets were non-binding, liberal targets, because we were trying to reach to the root of the problem. हम अभी प्रॉब्लम की जड़ तक पहुंच रहे थे। So that's why we just developed this kind of framework treaty, which was having non-binding targets, so that we could reach to the kind of genesis of the problem. Then we could just develop some kind of structural framework where we could impose binding targets as well. So this was there. Now this, after this Vienna Convention, which brought out a framework kind of idea to tackle the issue of ozone depletion with the non-binding targets. After that, a new thing happens. After the Vienna Convention, there comes the discovery of ozone hole. The discovery of ozone hole. Discovery of ozone hole in 1985. Same year the Vienna Convention happened. After that, but after the Vienna Convention, the same year, there came the discovery of ozone hole. This discovery was made by the British scientists. ये जो ओजोन होल की डिस्कवरी थी, इट वॉज मेड बाय द ब्रिटिश साइंटिस्ट। ये इंपॉर्टेंट है, एग्जाम में पूछा जाता है। द डिस्कवरी व्हेन इट वॉज मेड इन 1985 आफ्टर द वियना कन्वेंशन हैज टेकन प्लेस। ईयर इज सेम but the time is different, and this was made public by the British scientists. किसके द्वारा डिस्कवरी की गई? ब्रिटिश साइंटिस्ट के द्वारा। This could be the part of questions in our competitive exam. से पूछा जा सकता है। This is important, ये पूछा जा भी चुका है। So that's why I'm stressing over here. So the discovery of ozone hole, when it was made just after the Vienna Convention was concluded by the British scientists, so it further highlighted the issue. अभी वियना कन्वेंशन हुई ही थी, तब तक ओजोन होल की बात होने लगी, तो इसने जो है इशू को और अधिक हाईलाइट कर दिया। एंड व्हाट डज इट मीन बाय ओजोन होल? देयर इज नथिंग लाइक अ काइंड ऑफ होल इन द ओजोन लेयर। ऐसा नहीं कहीं पर होल हो गया है कंप्लीटली एज वी जस्ट अंडरस्टैंड द होल इन अवर नॉर्मल अंडरस्टैंडिंग। इट इज नॉट लाइक दैट। इट मीन्स the concentration of ozone at that particular place is coming down from the required limit. जितना होना चाहिए उससे वो नीचे आ रहा है concentration. When the concentration of ozone layer or ozone gas, when it comes down below 220 Dobson unit, जब ये 220 डॉप्सन यूनिट से कम होने लग जाता है तब हम उसको टर्म दे देते हैं ओजोन होल। When the concentration of ozone comes down below 220 Dobson unit, जब 220 Dobson यूनिट से कंसंट्रेशन इसका नीचे आने लगता है, देन वी टर्म दैट पार्टिकुलर प्लेस इन द ओजोन लेयर एज ओजोन होल, एज ओजोन होल बिलो 220 DU, बिलो 220 DU. Then we term it as ozone hole. तब हम इसको ओजोन होल का नाम दे देते हैं. एंड दिस द कंसंट्रेशन ऑफ ओजोन below 220 DU, it was discovered by the British scientists in 1985 over Antarctica. अंटार्कटिका के ऊपर ब्रिटिश साइंटिस्ट ने ऑब्जर्व किया कि ये कंसंट्रेशन 220 DU से नीचे चला जा रहा है. That's why they termed that there is ozone hole over Antarctica. Over Antarctica. Antarctica. तभी ब्रिटिश जो साइंटिस्ट्स हैं उन्होंने ये बताया कि ओजोन होल अंटार्कटिका के ऊपर है. नाउ व्हेन दिस डिस्कवरी केम, because this was not just discovered by normal researchers, this discovery was made by the British scientists, renowned scientists. So that's why the global community now became much more concerned. After this discovery, the global community started thinking about some kind of regime, ozone layer protection regime, which is concrete, which is just visible on the ground. मतलब ऐसा हमने एक वियना कन्वेंशन में ला दिया, नॉन बाइंडिंग टारगेट्स हैं, तो अभी क्या है कि बहुत लोग उसको मानते ना मानते. सो नाउ आफ्टर द डिस्कवरी ऑफ द ओजोन होल, वी स्टार्टेड थिंकिंग अबाउट some kind of concrete step in the direction of protecting ozone layer. Then we came with Montreal Protocol. Montreal Protocol. Montreal Protocol. Montreal Protocol. This protocol took place in 1987 at Montreal in Canada. In Canada. What is special about this Montreal Protocol? What is special about this Montreal Protocol? This Montreal Protocol, it brings down legally binding control measures, legally binding control measures to phase out ODSs, ozone depleting substances, meaning substances those are responsible for the depletion of ozone layer, like CFCs, halons. These are ODS substances basically responsible for the depletion of ozone layer. So Montreal Protocol, it brings the legally binding control measures, meaning legally binding targets. Vienna was not legally binding. Vienna में जो targets थे वो legally binding नहीं थे. But here Montreal Protocol, it further just takes the step and brings down legally binding measures कि अब हमें क्या करना है कि इनको phase out करना ही पड़ेगा. CFCs, halons, etc. Those are responsible for the depletion of ozone layer. Otherwise, the situation can be grim in future. क्योंकि ओजोन होल की डिस्कवरी अब हो चुकी थी. So it brings out legally binding control measures to just phase out कि हमें इनको अब हटाना है अपने यूज से, इंडस्ट्रियल यूज से या किसी भी यूज से हमें ओडीएस को पूरी तरह से समाप्त करना है हर एक देश को. So it was brought. But now after the Montreal Protocol, there came Kigali Amendment to the Montreal Protocol. Kigali Amendment. Kigali Amendment. Kigali Amendment to the Montreal Protocol. It came in 2016 in Rwanda. Rwanda is in Africa. So this Kigali Amendment was brought. The problem was that we brought the Montreal Protocol, decided to phase out ODS, and CFC was one of the ODSs. Okay, the world community started phasing out ODS, meaning CFC. जो वर्ल्ड कम्युनिटी थी उसने रेफ्रिजरेशन से, एसी से, फोम से सीएफसी को तो हटाना चालू कर दिया, फेज आउट करना चालू कर दिया. बट दे हैड स्टार्टेड यूजिंग HFC. They had started using HFCs, hydrofluorocarbons, on the place of CFCs. Hydrofluorocarbon, since it was not an ODS, hydrofluorocarbon ozone depleting substance nahi hai. That's why the CFC was phased out globally, and as an alternative, HFC was being used in refrigeration, in air conditioners. So this extended use of HFCs, later on we got to know that HFC is creating greenhouse effect. It is high potential greenhouse component, greenhouse gas, high potential GHG. HFC is just contributing in the issue of global warming. ये ODS तो नहीं है, ओजोन डिप्लीटिंग सब्सटेंस नहीं है HFC, बट इट इज कॉजिंग द इशू ऑफ ग्लोबल वार्मिंग. तब हमने ये जाना कि HFC जो अल्टरनेट लिया वो ओजोन को तो प्रोटेक्ट कर रहा है, लेकिन ऑन द अदर हैंड कॉजिंग ग्लोबल वार्मिंग, बिकॉज इट इज हाई पोटेंशियल एलिमेंट दैट कैन कॉज ग्लोबल वार्मिंग, HFC. So then after we brought out the Kigali Amendment, just to phase out HFC as well, to phase down HFC as well. कि हमें HFC को भी फेज डाउन करना है. ये ओजोन को तो प्रोटेक्ट कर रहा है, लेकिन ये क्लाइमेट चेंज को कंट्रीब्यूट कर रहा है, ये क्लाइमेट चेंज ला रहा है, ग्लोबल वार्मिंग क्रिएट कर रहा है. So that's why the Kigali Amendment was brought and HFC was put under control for phase down, and that's how we see that Kigali Amendment recognizes ozone climate linkage, यानी ओजोन और क्लाइमेट चेंज, इन दोनों को उसने लिंक किया किगाली अमेंडमेंट ने, कि हम ओजोन को प्रोटेक्ट करके क्लाइमेट चेंज को बढ़ावा नहीं दे सकते. दैट्स व्हाई विल हैव टू पुट डाउन HFCs एज वेल. तब से आफ्टर द किगाली अमेंडमेंट वी स्टार्टेड phasing down the use of hydrofluorocarbons as well, and HFCs, they were mainly used in air conditioners, in refrigerations, in foams, like that. So when CFCs were just phased down after the Montreal Protocol, we noticed that HFCs are being used by the companies, by factories, by different organizations on the place of CFCs. कि जो इंडस्ट्रीज हैं उन्होंने CFC को हटा के HFC यूज करना चालू कर दिया. बट HFC was causing global warming, high potential HFCs, they have high potential of causing global warming. And to just phase down HFCs as well, we brought Kigali Amendment to the Montreal Protocol, and that's how we established a linkage between ozone and the climate. There is a link between ozone and climate. We need to take care of both of them. So this was all about ozone layer protection regime. That's how the things unfolded, and now we are successfully tackling down the uses of CFCs and HFCs. We have phased down the use of CFCs almost more than 90%. So that's how we are just having the phasing down of CFCs and HFCs as achievements. And we are noticing nowadays that the ozone hole, which was discovered by the British scientists, is also getting refilled nowadays. वो फिर से वो अपने आप को वहां पर ओजोन गैस वहां पर जो 220 DU है उससे कंसंट्रेशन में आ रही है, that level. So the impact of the entire ozone layer protection regime is started visible now. We are just recovering our ozone layer which protects us. So that's all for today's lecture. Hope you enjoyed it, and just meet you next day in the next lecture with new topics. So thank you very much. Have a nice day.